Hello students, subject name is electromagnetic fields. It's third sem and fourth sem for the EEE students as well as the fourth sem for the ECE students according to Anna University. This subject is the basic subject and basic concept for the continuity of the subject in future semesters like antenna, wave propagation, RF system, waveguides, transmission lines, transmission and distributions. This subject is a prerequisite subject for engineering mathematics, engineering physics, circuit theory and circuit analysis. Mostly this subject for EEE and ECE paper. And basic is physics for lower class physics. We are going to see the unit name, time varying fields and Maxwell's equation. The repeatedly asking question satisfy the Maxwell equation one problem. Apart from that problem, they are asking to find current density or displacement current density. So see the problem or case. Sometimes it will be like a case problem. On topic called displacement current density JD. D is nothing but displacement, J is current density. Displacement current density. Question: find the amplitude of the displacement current density E vector equal to 80 cos of 6.22277 into 10 power 80 minus 2.092 y ax vector volt per meter. Epsilon r value is nothing but relative permeability is equal to 600. E vector is equal to one more E vector 3 into 10 power minus 6 sine of 6 into 10 power 60 minus 0.3464 x into ax vector coulomb per centimeter square. So they asked to find modulus of JD for first case of E vector. For second case they are introducing epsilon r value, then given another E vector. Again you have to find modulus of JD. That amplitude is nothing but modulus of JD. The formula, this is a formula. JD is equal to dou d vector by dt. JD is nothing but displacement current density. D vector is nothing but electric flux density. Therefore, JD vector is equal to dou d vector by dou t, which is equal to dou by dou t of. So, D vector can be written as epsilon into E, where epsilon is called as epsilon naught epsilon r into E vector. Take this D vector and substitute here. Therefore, dou by dou t of instead of D vector epsilon naught epsilon r E vector. Now, JD is equal to, take epsilon naught outside, dou by dou t epsilon r into E vector. What is epsilon naught value? 8.854 into 10 to the power of minus 12 of dou by dou t of. What is epsilon r value? Not given first case 1. What is E vector? Directly given in the question as 80 cos of 6.277 into 10 power 80 minus 2.092y into ax vector. Okay, then do the differentiation of the cos, you'll get the sign value, minus sign. Then multiply, then you get the final answer, JD equal to minus 0.4446 sine of 6.277 into 10 power 80 minus 2.092y into ax vector. Now, once find out the JD, find the amplitude of JD. Amplitude of JD is nothing but modulus of JD is equal to minus 0.4446. For current density, the unit is ampere per meter square. Second case of the problem, when epsilon r is introduced as a value called 600. Just introduce 600 for the new E vector. Again, the formula for JD equal to dou d by dou t can be written as D vector is equal to epsilon naught into epsilon r into E vector, which is equal to, take epsilon naught outside as 8.854 into 10 power minus 12 into dou by dou t of epsilon r value is given as 600 into E vector is given as 3 into 10 power minus 6 sine of 6 into 10 power 60 minus 0.3464 ax vector. Then differentiation of sine becomes cos. So do the necessary differentiation. Then you'll get the answer called 18 cos of 6 into 10 power 60 minus 0.3464 x into ax vector. Now take modulus, that is amplitude, you'll get only 18. So first case the JD is minus 0.446, then once take modulus it becomes plus. Next JD is 18. This problem is a unicity 8 mark problem. I have to calculate the displacement current as well as the displacement current density. Thank you.